Okay, we're going to look at creating graphs today from knowing information about their limits and or the continuity or discontinuity. So they're going to give us a bunch of information. If they say like f of 2 equals 1, that tells us where to put a solid point. If they say f of x equals a certain number, we're going to put a horizontal line, and they'll typically specify at which x values. If they tell us the graph has removable discontinuity, we know to put a hole there. Okay, and remember, when you have a hole, both sides of the graph at that point are connected to it. If they tell us it's non-removable, we're going to put a jump there. Okay, you could sometimes put an asymptote, but we typically always just put a jump there. If they tell us that the limit doesn't exist, okay, well, that tells us that there's going to be a jump in the graph, so we need to make sure our points are disconnected. And then if they tell us the limit is a certain number, that means the graph meets at that specific point. So let's look at a few examples. Sketch a graph with the given properties. So they tell us f of 2 is 3, so that means we have the point 2, 3 on the graph. F of 0 is 2. So I'd have 0, 2, and then my last solid point would be negative 3, 0. So I'm going to go ahead and graph all three of these. And then they tell us the limit as x approaches 0 does not exist. So that means right here at x equals 0, I need to have a jump at this part of the graph. Okay. So what I'm going to do is I'm just going to start from this point and I'm going to connect it to either 1 to the left or 1 to the right. It doesn't matter. I'm just going to go this way and then continue the graph to the right. Okay. Now I need to connect to this point, okay, but I've got to first create a jump. So I'm just going to go somewhere on 0 and put an open circle. You cannot have two closed circles, otherwise it wouldn't be a function. Okay, so you can pick anywhere on the y-axis to put your open circle. Okay, just not at this point because we need a jump. So we need these two parts to be disconnected. So from this point, this is where I'm going to pick up and connect to the other one. Okay, and then I'm just going to keep going. Now these like end pieces here, I drew a horizontal line here, but you could have kept going straight, you could have gone down, you could have done like a sine function, same thing here. So these little endpoints, I usually just draw whatever seems easiest to me. Now let's look at another example. So this time they tell us f of x equals 3. So that's a horizontal line, and it's only for the x values between -1 and 3. So I'm going to draw a horizontal line starting at -1, okay, with an open circle because I don't have an or equals to here. And then I'm going to go all the way to 3, also with an open circle. Okay. So we have this one portion of the graph. Then for our limits, they tell us at the limit as x approaches -1 from the left. So that little negative there means from the left is 2. So that means as I draw the graph from the left side of -1, I have to end up at y equals 2. So I need to end up at this point right here. And I'm just going to make it solid because this one was open, but if you wanted to do two open circles, that's also okay. Okay? So I just need to have the left portion of the graph, so this part right here, connected to this point. Okay. Now it doesn't have to be a horizontal line. You could have done a line like this, you could have done a line like that, you could have done a parabola. Just whatever shape is over here has to be connected to the point at 2 so that the limit from the left will be 2. Now they tell us the limit as x approaches 4 has to be 1. So this one doesn't give us a direction. It doesn't say from the left or from the right. So that means we have to have a point at 4, 1. Okay, and again, with limits, it doesn't matter whether it's open or closed. You can choose to make this a closed circle or an open circle. Okay, but since the limit from both sides is 1, it means the part coming from the left has to be connected to that point, and the part to the right. Okay, so this part and this part have to be connected to this point. And again, this little part right here could have been whatever you wanted. I just typically do lines. So for this next one, we have f of -1 is 4. So I have a solid point at -1, 4, and then another solid point at 1, -2. Then I have removable discontinuity at 1. Okay, so that means at 1, I have to have a hole. Okay. Then at non-removable discontinuity at -1. So here, I have to have a jump in the graph. So I'm going to just start the graph to the left. So I'm going to create a jump here. So I'm going to have this one go that way. I could have done it from the top one too. Okay. And then I have to create a hole at 1. Okay, so just somewhere here, I'm going to put a open circle at 1. And remember, for a hole, the graph has to be connected to it. Okay, so I ended here, so I'm going to pick back up at this point. So I'm going to go ahead and connect to this one and then keep going from that point. So this one right here is just a random point by itself, okay, because they told us there has to be a hole at 1. Okay, so this open circle could have been anywhere along 1 except for this point. I just chose to put it next to the other one. Okay, and this portion and this portion both have to be connected to the hole. Okay. So again, this isn't the only thing that works, but it just has to be something that meets all of these conditions. So like another way you could have done this is I could have just connected these 2 points. Okay. So that would still be a hole at 1, okay, because the left and the right side would both be connected to it, and then I could have just extended the left side of the graph from the solid point. So there's not just one specific answer. Okay? It can be anything that meets the given condition. Now for our last one, we have f of 0 equals 4, f of -3 equals -1, then the limit as x approaches 0 is 1. So that means at 0, okay, the graph has to meet at 0, 1. So since I already have a solid point here, the point at 0, 1 has to be open. Okay. And then I have to have this part of the graph and the right side of the graph connected to that point. So now I know I'm not done, but I just wanted to draw that in so that I remember I have to be connected to this point. Okay. Well, then the last thing they tell us is that we have non-removable discontinuity at x equals 1. So that means right here, I need a jump in the graph, which I currently don't have. So what I'm going to do is just erase the graph to the left of 1. And I'm going to stop it here, okay. And then you can put a solid point, open point, it doesn't matter, okay. But then I'm just going to pick somewhere else and then start the graph to the right from there. So now I have a jump in the graph.